Oh, there we go. All right, exponent properties. So turn to that next page. It has the excuse me. It has the blank lines on it. The page after the graphing that you were just doing. Exponent properties. So a couple of comments that are definitely true. You feel like you did this in geometry. True. You feel like you did this in Algebra 1. Also true. Maybe you've done a little bit of it even in pre-algebra. True. You keep using it again and again and again. It shows up on the STAR test. You need it moving forward. Like we don't test it specifically much after Algebra 2, really. But you have to use it. In fact, we were using this exact stuff in calculus yesterday. So like the question wasn't, do you know your exponent properties? It was, can you integrate this expression? But in order to integrate the expression, you don't even know what I'm talking about, you had to know your exponent properties. So it's building blocks, building blocks, building blocks for future use. So yes, you will have seen all of these, I think. And in theory, you know them all, but you don't use them enough, maybe. And when we make them harder, they get trickier. So the properties are going to look easy, and then we'll apply them, and it'll be like, ooh, x to the 0. What's that? That's 1. Anything? I'm going to say almost anything to the 0 is 1. 0 to the 0 is undefined. You got to wait till you get to calculus to figure out what that's about. That doesn't have an answer, right? Like little side note, because 0 to anything is 0, but anything to the 0 is 1. So is that 0 or is that 1? Nobody knows. Undetermined. Indeterminate is the fancy. So we'll hold off on that. You're not going to have to worry about that. But we do need to be careful because, yes, every math teacher up until now has probably said anything to the 0 is 1, and you're like, almost anything. There's one thing that's not. So as long as it's not 0, anything to the 0 is 1.
What would you use 0 to 0?
Well, it shows up in calculus, and it's not the final answer. You have to do other stuff to change it up and figure out what the answer is. That's a longer answer. How about x to the m times x to the n?
The things would add, right?
They would add. So m plus n, not m times n, m plus n. Sometimes a simpler, not n plus 2, m plus n. You don't need a cheat sheet for this. Like, here's another example that's maybe a little easier. X to the 5th. X squared times x cubed. That's x to the 5th. Because you add them. Correct. What if you had x to the m over x to the n?
Then you would like multiply the n up somehow? I don't remember how you do it.
You know what? Let's work what might be an easier one. What's x to the, we'll go 8. What's x to the 8th over x squared?
X to the 4th.
Ooh, careful. It's not x to the 4th.
6.
X to the 8th. If you ever get lost, you can write them all out. There's x to the 8th. There's x squared. So how many x's can I cancel? 2. And how many are left? Now, we don't really want to do that every time, right? So what's the shortcut? Subtract m minus n. What if it was the other way? What if it was x squared over x to the 8th?
Then would it be? Oh, you would have to do the thing where you do like x to the 8th over x or something like that.
Well, how about we just think about it like we did this long way here? I don't want to write them all out again, but I could. What would happen if I wrote them all out again?
You have 0 over x.
I'd have x to the 6 in the bottom, but it wouldn't be 0 in the top. It'd be 1.
But can't you not have an exponent in the bottom?
Okay, that just depends on the rules. So that sort of leads to our next rule, though. We'll get there in a minute. What about x to the m all raised to the n.
Oh, you multiply.
Those are you multiply. A power to a power you multiply. So x cubed squared
That's like x to the 6.
is x to the 6. If you ever get stuck on these, you can remind yourself the rule, because x cubed squared would be x times x times x times x times x times x is x to the 6th. I mean, the hope is you don't ever have to do this, but if you get stuck somewhere and you have a brain freeze and you can't remember what to do, then think back to an easier problem, work it out, and then realize, oh yeah, all I needed to do was multiply the 3 and the 2. So I don't want to see this on your paper, but if it comes to it, that's how you can remind yourself what the rule is. What about a negative exponent? What does that do?
That's the one. That's the one where you have to take it to the bottom, right?
Yes.
You have to put it on the other side.
That sends it to the, I would say it sends it to the other side. The other side of the fraction. Rather than saying it sends it to the bottom, because what if you had 1 over x to the negative n? I mean, it would be 1 over, but an easier way to say that would just be x to the n. So a negative exponent flips it to the other side. That's the easier way to say that. Don't say it sends it to the bottom, because it's already in the bottom, then where does it go? So it flips it to the other side of the fraction. If it's in the top, it goes to the bottom. If it's in the bottom, it goes to the top. Okay. I hope those rules look familiar. Ish. But then you turn the page and you're like, what the heck? Why are we doing this crazy stuff? Okay, again, the assignment is the odds. That's fair. It looks difficult, but I don't think it really is. I think that's a true statement. We're going to work some of the evens together. I know you don't like that, but because people struggle with these, I want to leave more for you to practice with. That's really the reason. The square roots weren't too bad, so we worked a bunch of the assigned ones. But this one, we're going to work the unassigned ones. Okay, so I got, what do I do first? There's a ton of things going on here. I think I would work on the inside first, and then we'll worry about the negative 4. So you could do the negative 4 first, but let's talk about that later. Let's fix the inside. So we say fix the inside. So that would make it y cubed at the bottom. And this is going to get tricky because you're going to start skipping steps, which is okay, but how many steps can you skip at once? All of them is not the right answer. So yeah, we could send that y to the bottom, and there's already 2 down there, so that makes 3 down there. We could reduce some of the x's. So how many x's will be left? 2 at the top.
Oh, I wrote it wrong.
And again, skipping a little bit of steps, or at least doing multiple steps in one. What about the y's?
Probably not. Well, it could be y2.
Y2 at the bottom. What about that 2? It just stays where that is. Not done yet, because the instructions say it, only positive exponents. So we've simplified, but we have a negative exponent there, so we're not done yet. Cash?
Would we do the negative 4 times the 2 as well?
Yes. Be careful, it's not times the 2, though.
Yeah, it's to the power.
It's to the power. So 2 to the negative 4, x to the negative 8, y to the negative 8. That's a step that some people wouldn't show, because you're going to flip them. This y to the 3, because this y to the 1 went downstairs. So that y to the negative 1 became a y in the bottom. And then y squared times y, that's 3 y's down there, y cubed. y to the negative 1 flips the y to the bottom. Got it? Okay. Okay. So the x's and the y's are easy. Those just flip sides. Y to the 8th, x to the 8th. 2 to the negative 4th flips sides, but I can also do 2 to the 4th. 2 times 2 is 4. 2 is 8. Times 2 is 16. Yes, it's positive, but it's in the bottom. The negative exponent flips it over. It does not make it negative. It does not make the value negative.
What if it was negative 3?
Doesn't matter.
Oh, because we're flipping it.
The negative flips it.
Yes, okay.
Now, some of you are going to show fewer steps than I did. That's okay. Some of you are going to get real ambitious and try to do all of that in your head at once.
I might not do that.
Yeah, please don't do that. Like, you need to show some intermediate steps on these really, they're not hard, there's just so many pieces to them.
Just start cross-dragging you out.
Let's look at number 6.
I never said I was going
Now, there's a few things you can do that, like, what can we do first on number 6? There's like an obvious, the y's are gone. So that's easy. So what does that leave?
Ooh, that would just be 1 over 2x to the 5th.
1 over 2x to the 5th. Yes, because we'll combine those x's.
We're in the negative 3.
I'm not done yet. So what's the negative 3 do?
It flips it.
It flips it and cubes it. That's one way to say it. The negative flips it.
8.
And 3 cubes it. Some of you are going to do that all at once. Others of you are going to like distribute the negative 3 first. But both of those would flip over because they're negative. So 8x to the 15th. Right?
That's 3 times.
3 times 5? Power to a power? Let's look at number 10. Powers to powers to powers.
Can you multiply the 4 and the 3 first?
Can you do what now?
Multiply the 4 and the negative 3 to get negative 12?
I don't know. I would find. I would go and do the.
Why could you not?
Oh, because it's only parentheses.
It's only in the top. Yeah. So yes, that would make negative 12, but you'd have to be careful about the bottom. So I think it would be wiser to just start from the inside and start cleaning things up.
I really want to know if my mental math is right there.
You skip to the end?
Yes.
Yes, y to the 0 is 1. Like, why did they even put that in there other than to mess with us a little bit?
But then you flip the x because x 3 can't.
Okay, how many x's are there? Let's see. Inside the negative 3, I got x cubed and x to the negative 1.
That'd just be 1 or 2 x squared.
That'd be x squared. So those two make x squared.
2x squared.
How many y's are there?
1.
1. And then that's to the negative 3 over x squared, all to the 4th. Can I cancel those x squareds? It's so tempting. They're right there. Why can't I cancel those? Because that negative 3 up there. So that's tricky.
My mental math is not.
So 2 to the negative 3, x to the negative 6, y to the negative 3, over x squared. This is me not doing mental math. This is me showing my work. So what about 8, and where is the 8? Like 2 cubed is 8, but where is it? On the bottom, because the negative exponent flips it over. So that's an 8 in the bottom. What about this? Hold on, you're not going to have to go that far. What's x to the negative 6 over x squared? What's that end up as? X to the 8th, where? On the bottom. Because that x to the negative 6 would go to the bottom. I got a squared and a 6 in the bottom, so that makes 8 of them in the bottom.
What's
And that would just be y cubed in the bottom.
Wait, 4096 over 1. I put it in my calculator.
When you get crazy numbers like 8 to the 4th, you could just leave it as 8 to the 4th.
Oh, let's go.
8 times 8 is 64, but then it's like, wait a minute, 64 times 8? And then that times 8? Or 64 times 64?
4096.
How about just 8 to the 4th?
Oh, I messed
Show your work, show your work, show your work. Please, for your own benefit.
Wait,
Oh, wow.
32A.
I don't know. So why did this?
Always get X negative 6.
Wait, where's the 12 line?
Oh man, now we're,
Oh shoot, wait.
you guys are racing ahead.
Why 3 4?
Jack, you good or not?
Oh, I see. In the first step, I combined the x negative 1 and the x squared, but you can't do that.
Well, you could combine those.
And no, the
Oh, you combined this one as well.
yeah,
Yeah. And why can't you include that one?
it's not important.
It's not in parentheses with that other one has a negative 3 out there, so.
I'm gonna just leave it.
Yeah, you could leave it, that's fine, because your only assignment is the odds. Man.
I don't look back at this anyway.
You never think
I don't always do that.
Let's get number 18.
Take notes. That way I don't get shouted at.
I think this is easier, but
What's that?
I think it is.
we can cancel this.
You can, but be careful. You have to cancel them out like one at a time, like one piece at a time. And maybe it's wiser to write it all out. Sort of separate out. Right? We had a common denominator. We added the numerators. But if we want to simplify, we need to break it back out again. So yes, you can do x to the 4th over x squared is x squared. But I wouldn't do it here because then you sort of lose track of the x squared being able to cancel with the 5x.
Or the 1.
Or the 1. So not hard as long as you do that first step of realizing that it's each term over x squared.
Wait, that's just
And that's just the answer. If you wanted to combine those and get a common denominator, you're shaking your head no, but what would your answer be if you combine those with a common denominator?
the top.
Be right back where you came from. So, just a preference. So you want it like this, you want it like that. Kind of depends on the problem. And depends on what you're doing with the problem. This is another one that we did something like this in calculus yesterday, where we wanted to integrate. Ooh, there's a symbol you don't know. But you can't really integrate when it looks like that. It has to look like this, and then you're ready to integrate.
What's integrated?
Exactly. I'll see you in 2 years.
That's
Yeah.
if we're still in school.
If you're still in school. I don't think any of you guys are at risk of dropping out. I hope not.
Do you teach BC as well?
I haven't taught BC in a long time.
I'm gonna come talk to you
BC is the harder one because
when you're teaching. I know which one to sign up.
Maybe I'll just take it.
Wait, if I just fail this.
look at it 22. Any thoughts on?
Mr.
I don't like that X in the bottom. So how can I
To all of them.
do what to all of them?
Oh, you like do the split it up thing that you did in the last one.
Oh, because you won over
I could. I just don't like that X in the bottom though.
multiply everything by x.
So let's multiply everybody by X. That'll fix that.
So don't you do it?
But what else would I have to do?
Multiply the bottom by x.
Multiply the bottom by X.
X squared.
Oh yeah, that'd just be a square.
So X to the 4th minus 5x cubed minus 4x squared minus x minus 1 over x squared.
Start combining.
And then most of you are probably not going to write out like we did on number 18. You are going to divide each of them by x squared, but you don't have to write it out individually. You can just say, I think it's almost all the popsicle sticks today. Liam, what's x to the 4th over x squared? Just going to take this one at a time. X squared. Allie, what's negative 5x cubed over x squared? Negative 5x. I'm going to run out of colors. I'm not going to run out of popsicle sticks, though. Rena, what's negative 4x squared divided by x squared?
I like the statistics.
Negative 4. Back to black. And then Preston, how about what's negative x over x squared?
Set everything before this together.
Ryan tried to whisper it to you. Does that make sense? One of the x's will cancel, and you'll be left with negative 1 in the top. One of the x's will reduce. Right? Again, if you get stuck, write it all out. And then be like, oh, I can cancel an x. And that leaves me with negative 1 over x. And then lastly, 3 popsicle sticks left, but they've all talked today, so it doesn't really matter who I pick. Kennedy, how about negative 1 over x squared? What's that equal to? Yeah, no, it's like, well, I just gave the answer, negative 1 over x squared. And I had enough colors to pull that one off. Okay, so your assignment for the worksheets today are the odds on both of those. By the way, peek ahead for just a second. Review of exponent properties. Review meaning later, not today. So it's stuff that we just did, but it's a built-in more practice. But it's not assigned yet. It's easy. It's probably easier than the other ones because it's multiple choice. All right, so you've got 2 worksheets where the odds are assigned. You should have finished the first one already, and now this leaves you with 10 problems left to do, 11 problems. 7, 8, 9, 10, 11. 11 problems in 25 minutes. I have faith in you. Do we need to look back at number 1? All right, you try number 1. And how many? Well, before I use the 4. 3 of them. Let's see, the 2's already went away. I've got all the 4's handled, or the y's handled. So y to the 16th over x to the 12th. Show some work. Don't try to do it all in your head. Show some work.
I'm confused on 3. The n squared. The n can still combine with the
I got
n
1,
bottom,
M2,
right?
M7.
Okay,
1
that's
over,
what I got.
1 over M2 is M7.
That's what I got.
Let's see.
There's so many mistakes that
There are so many mistakes that can be made.
So many steps.
That is absolutely true. Let's see. How many m's do I end up with? That's an easier one, I think.
Wait, what did you do for T?
I did this first because I figured that's pretty easy to handle. Knock that out. And then m's look easier to deal with. So how many m's do I have left?
2.
How many m?
Wait.
3, and where are they?
On the bottom, right?
So 3 m's in the bottom.
But then you have a negative. Oh, wait, never mind.
That's an n. So how many, here's where, how many steps do you want to do at once in your head, kind of a question.
Wait, where did the squared on the end?
Oh, yeah, no wonder that doesn't look right. That's m squared. So that means this is m squared in the bottom. Is that better?
Sure.
So how many n's are left? 7 of them, and where are those 7 n's? In the bottom. And there's a bunch of different ways to get there. I would probably move this one down. That would make n to the 8. And then 1 and 8 subtracts the 7. Don't forget the 1 in the top. Some of my favorite wrong answers would be m squared over n to the 7th. Okay, all the top went away. Like, it went away, but there's still a 1 over. So I hope that seems dumb to you, but
For 5,
And then on 5.
when you send out your 2, does it also go to 2x? Does it become 4x squared, or is it just 2x?
it becomes 4x squared. That's right. And then I think there is. I'll look. Let's see. I combine all those y's, and I get 9 of them.
Yes, 7.
And then,
And then that would be negative 2x. Like the negative 2x.
yeah, 2x to the negative 2. Right? Because I've combined the negative 3 plus 1 is negative 2. And then, oh, this messes people up. What moves up to the top out of this stuff?
Just the x negative 2.
Just the x to the negative 2, not the 2, because the 2 doesn't have a negative exponent on it. It might help to like explode it out like this. So that x can move to the top, but that 2 stays in the bottom. Although, back to color coding.
So you could just...
4 divided by 2 is 2.
Oh my goodness, I'm right.
Where do I land? How many x's do I end up with? And where are they?
4.
4 in the top.
And then 9 y.
And that y to 9th is still in the bottom.
So if there's a multiplication sign, you can kind of just ignore that, right?
I mean, kinda.
Just multiplies it in, right?
Like, it'd be the same as if...
It'd be the same if it wasn't there, so that means the same thing as ignore, yeah.
Okay.
Yeah. That's fair. 7 looks like it's a little bit easier.
Yeah, 7.
7 is a lot easier.
Oh, he's just doing it all.
No, he's walking us through we're asking questions.
Yeah, 7's not bad. Again, show your work though. It is tempting, and some of you are probably able to like move all of the things around at once and land at the right answer. Just tempted to show you how to do that, but I don't want. I probably shouldn't.
You should show us.
You should.
Like how I would do number 7 without showing any work.
Because I'm going to be doing it anyways, you might as well...
May as well coax you how to do it. So I would handle the numbers first. Jack's talked me into it. So the numbers are, there's a 2 in the bottom. That's the only number. It's not changed, so I know the answer will have a 2 in the bottom. Then I would look at the x's. And so I start thinking about the x's. Well, I got negative 4 of them in the top, 2 of them in the bottom.
So that makes 6.
So that makes 6 in the bottom. There's my x's. And then I think about my y's. 3 of them and 4 of them make 7 of them. 7 in the bottom. But better put a 1 in the top. Yeah, don't leave it blank.
Alright.
That's another fun one. Blank over. No, there's something up there. It's a
How would
1.
you feel if I just did that?
I would be frustrated.
How would you be?
But I have seen this answer before on this section.
No, yeah.
Well, Mr. Wolf, it all canceled out. Like, well, I mean, yes, but it doesn't cancel out to like nothing. There's still a 1 there. I mean, that's like, what's 4 over 4 equal to?
1.
Nothing? Like it just goes away? Like, no, it's 1.
Yes, it goes away.
It just goes away. It just equals, there's my answer, right there, in the empty box. because they both canceled, right? It's like, no, there's a 1 there.
Jackson, I made it to the back.